Hello everyone and welcome back to the second part of Norm, how to use Norm for OpenCV in the Titan 2. In this video I'm gonna be showing you guys how to use Norm. I made a video before showing you this program script that I made and how it's useful to compare the Norm that we're gonna do today. So let's move on. The program that I'm gonna be using, or sorry, not the program, the game that I'm gonna be using is gonna be Final Fantasy X. So we're gonna start a battle. I'm gonna start running on circles because I would like my program or what I want to compare is that as soon as I start the battle, and it's Tidus, the one who is showing in this corner here above. So I want the program to do an action for me, or at least let me know that it's his turn. So the way we're gonna do that is by, you might not see it, but the square is right here. You can see that it's growing, but over here it turned negative. That means I'm turning the wrong coordinate. I'm moving x1. I should move x2. So now it's being positive. So this time I'm gonna keep clicking the right, yes, the right button, the right D-pad until I see this corner here approaching right the probably here. It's not gonna be perfect, but we're gonna work on it later. So now I'm gonna press one more time LV to move it to X1, Y1, and we're gonna push up all the way. You see how this is turning crazy here? Because I'm pressing up, right? If you don't want that and that is annoying for you, as I showed in the first tutorial video, you can press the RS or R3 button and it will freeze the frame for you. That way you won't see anything moving, just the blue box. So I kind of like it over there, the blue square how it looks now. So I'm gonna start closing this corner here. It's getting closer. This is a little bit annoying because it takes a while, but other than that, it should be pretty fine. So let's see. It's getting close. There you go. Okay, now I'm gonna press LV one more time because now I need to change the X2, Y2. Why? Because I want this corner here to be small, to the size of the picture of Tidus. So I'm gonna push up until it is this size, hopefully. Hopefully close enough, but it doesn't really matter as long as the computer can actually tell the compare good the picture. As long as you're not showing two characters like this, you're fine. So just like that, I think looks good. Let me just bring it a little bit more down, a little bit more to the left. Okay, and let's see. So I'm gonna take the picture now by pressing the LS stick, and you're gonna see a JPEG and a text file has been created on directory, and it tells me the directory. Now I'm gonna open PyCharm, and it should automatically show me the two images. Sorry, the image and the text. So in the image it show me Tidus, but Tidus, I don't like this corner here. You might notice that it looks kind of blue, and that is because of the background. So if we're in a white background, it will look different. So for that, I'm gonna change X1, Y1 one more time. I'm gonna make it a little bit smaller. So let's see now. I'm gonna take another picture. Let's see the result. Now it's only the image and nothing else. So this is what I want. So at least we got the picture. Now this is what we need for the norm, but we also need the coordinates. The coordinates is right here. So I'm gonna copy it. I'm gonna keep it with me. And now what I'm gonna do, and this is normally you don't have to do this, but every time I play a game, because I wanna keep it organized, I like to make a folder, and the folder call it the name of the game. So that way I know exactly uh, what program I did for that game specifically, and I don't have a mess of programs around. So Final Fantasy X. Then inside, I'm gonna call it, I don't know, I'm gonna make another folder called battle. And inside battle, I'm gonna add a new folder, call it images. I always add a folder called it images on every program that I make. Doesn't matter which one. So what I mean by that, I'm gonna show you an example. These are the games that I make. So if we take for example Minecraft, sorry, not Minecraft. Minecraft is different. Well, which one was it? It was XV. Yeah. So in XV, I made a folder called images, and in images, I have the letter X, which is the one that I did on the video in the tutorial. So now, what I'm gonna do is I'm gonna take this image and gonna give it a new name. And the name, we go to refactor name, and I'm gonna call it his name, Tidus. Now, what I'm gonna do is I'm gonna pass this image to his folder. So now in images, you're gonna have the picture of the character. Now these coordinates, I'm gonna pass it to battle, or you can pass it to images, however you like. You know what? Let's pass it to images too, because that way they all gonna be together, because it's gonna have the same name. Or you can just call this, I don't know how that's called, because it's not only him. It's gonna be all the, I don't know, characters. I'm gonna call it characters. So now in characters, we got the coordinates, and here is the image of the character Tidus. So now let's build the program. So for that, what I'm gonna do is I'm gonna open GTuner IB, and I'm gonna click on File, New, and I'm gonna click on New GCV script. I'm already on YouTube, but I don't want YouTube. I want the new folder that I'm in inside battles, and that's it. I'm not gonna do it in images. I'm just gonna do it in the folder battles. So now I'm gonna click on select, and I'm gonna give it a name. Uh, let's call it battle again. So now that we got battle, so we are not gonna program it here. As soon as I create it, I already got the default code that we're gonna need. So what I'm gonna do now is I'm gonna close it here, but I'm gonna open PyCharm, because PyCharm makes it a lot easier for me to program code. So I'm gonna open battle, and here is where I'm gonna write the coding. So the first thing that we're gonna do is the code that I had on my text file, I'm gonna copy it, and I'm gonna paste it right here. The first thing that I'm gonna do. And that way now the computer knows exactly where to look. And I'm gonna show you how this works. You know what? I'm gonna change the name to picture. Just call it picture completely. So picture and frame. Let's see what's the difference between frame and picture. So the frame should be the image of the game. It is grabbing the image from the console. Right, so if we go back here to computer vision, I'm gonna close this code, and now I'm gonna refresh it, and I'm gonna see battle here. Now I'm gonna play it, and you're gonna see that nothing is gonna show up. It's just gonna show up the game. You see, nothing special about it. It's just the images. But every single movement is a frame. A picture per second, I think there are 60 images per second. That's why it looks so smooth. It looks like a movie. However, look what happens if we close it. Again, it's closed. We're gonna go, oops, sorry. We're gonna go to PyCharm, and instead of frame, we're gonna call it picture. Now we're gonna run the code again. You don't have to click save or anything. It saves automatically in PyCharm. But if you feel like it's not saving correctly, you can click on file and click on save all. Now look what happens if we run the same code. It's the same one battle, but this time it's returning picture, which is the frame and a little block from the frame. It's gonna return this picture. It looks like, oh, but you might be thinking, but you're just grabbing this image and that's what you're showing me. But actually no, it is taking that from the game, from the actual frame. So it's only showing you that specific corner. You told the computer, I want you to show me corner from number 196 in the y-axis all the way to 238, and from the x-axis 1654 all the way to 1718. Now that's why you only see this picture here. Now just to show you that is true and it's not a lie, I'm gonna put frame one more time, and I'm gonna just close it. Now I'm gonna click the green button again to run it, and you're gonna notice that again the game is showing normally. Let's pass Tito's turn. What the hell? Oh, come on. No, I don't want it to change. So let's just attack. And now we're gonna do the same thing. Now you see that it's Waka's turn. This character's name is Waka. So let's see if I do the same thing again. If I show picture, would it show Tidus or Waka? Well, let's see. I'm gonna close it. Now I'm gonna run it one more time, and you're gonna notice that the character that is showing is Waka. From the picture so it's not grabbing this picture. It's actually grabbing here, this corner here. So the character turn already passed because I already attacked. Now this character is the one at the top, and that's why it's showing him. So it's not saying like, okay, let me see what character is the next one. Oh yeah, it's him, so let's show him. No, it's just showing that corner right there. Let's close it one more time. Let's close this, and let's just return frame for now. Because I mean, you don't need to only return picture. The computer can show you the frame. That doesn't matter. What matters is what code you put here. So the next step is to do the norm. So let's do now how to use norm. So we're gonna create a self variable, and this variable we're gonna call it template, because here is where we're gonna read this picture here. We want the computer to compare this image here with, I'm gonna show you error. Oh, sorry. The reason why it's giving me the error is because of this. So let's do this first, and then I'm gonna run the code. The reason why I'm gonna do the template is because I'm gonna read the character Tidus. So for that we need to call CV2, this here CV2, and put a dot and say I'm read. That means read this file. We're gonna put quotes, or you can put the double quote or single quote, but single quote works fine. Then I'm gonna go to the folder because this is where the script is. So this, to find the Tidus JPEG, you're gonna have to call this folder here first. But if you just save Tidus next to the file or in the same folder, you don't have to. You just have to call the file, and that's it. But in my case, I have to say images dash, and now put the letter T, and it will appear for me automatically. I just double click it and it will fill it for me. Now if I try to run this code again, you're gonna notice that it works, but nothing special is gonna happen. It's just gonna display the same thing. But that's because I haven't done anything with this file. Oh, and also what we do is, or what I do always, is I put whatever self I do here, I also add it here to delete. So now we're gonna compare the norm. But how do we do that? Well, to do that, we're gonna create a new variable. This variable, you can always put it here. You don't have to call it outside. You don't have to call it here inside. You can call it here. It's fine. I always call it similar, or you can call it whatever. You can even call it A or B or C, whatever you want. I just call it similar, and then I say the word equals to. Now I'm gonna say CV2 one more time, just like here. But instead of calling CV2 I'm read, you're gonna say dot norm. So we're gonna call the norm. In the norm, I'm gonna call self, because we got this self here. You always have to use the word self. if you want to call one of these variables, you're gonna say self dot template, right? So basically, you're saying to the computer, grab this image, and I want you to compare this image right here, which is this one here, and this image here is Tidus, because it's showing this only. I want you to compare this image with, now, you might guess it, picture, because picture is the frame, is the that specific block that you wanna compare with. So you're just gonna call it picture. And just like that, the computer will always tell you the value in comparison, like how close is this file to this one. But it's gonna say a by number. If you're just curious and you wanna know the number, you can say print and just say similar. But it's gonna tell you a bunch of numbers, like sometimes you don't even see them. So to test that, we're gonna do a one right now. We're gonna say close. Now we're just gonna run it one more time, and you're gonna notice here that it start pumping a bunch of numbers. It even get invisible of how fast it's going. But if we stop it, you're gonna notice that the number always says 7,188 and a bunch of decimals. That is telling you the difference in this number is like this value is very different. Now let's try with Lulu. Lulu is this girl here. So I'm gonna attack with Waka right now. You might not see it, but I'm gonna run the code now. Now this is Lulu's turn, and you're gonna notice that her value is now different. Let me stop it for a minute. So her value is 9,930. She's even much different than Tidus. But now the next turn is gonna be Tidus. I'm gonna run it. You might not notice it right away, but it's just telling me a bunch of files. No, sorry, not files, a bunch of digits. So now I'm gonna attack with her. I'm just gonna do a random attack. Let's use fire. Okay, so now that it's Tito's turn, you might notice that the value dropped very low. From 9,000 or 7,000, now it's like 400 only. Yeah, 484. That means this image here that is looking at right now, it is very close to this file that we gave it to, the Tidus. So the computer is saying like, wait, but this one is very similar to this one. So yeah, they're pretty close. So the value is low. Um, with this, what you can do is, and now we know that the lowest value we can get is 484, but that depends the map. If you're in a much clear day map or dark map or in underwater, it might change values. So just to be safe, what I constantly do is I can do this. I can say something like if similar is less than or equal to, it was 484, so I'm gonna say 600. Then print, you can say found Tidus. So let's see if this works. If it's less than 600, it should print always find Tidus. So we're gonna run it one more time, and we know that it's Tidus' turn, so it should print found Tidus. Yep, but it keeps printing it forever and forever and forever. So now what I'm gonna show you is a way that you can actually print this only once, and you don't have to go to the cycle of, like, you can barely see the information. So for this, I do a small trick that I create a new variable, call it self dot found, or you can call it anything you like. It doesn't matter what the name you give, as long as it's a boolean, you're fine. So in here, we're gonna say if it's less than 600 and self, we're gonna call this boolean here. The boolean means like if it's true or it's false. True means like yes, I found it, for example, and false means like no, it's not there. So if it's true, then just tell me, like, print something. So I'm gonna print the same thing, found. tidus. So now, but the secret to only print it once is to turn self dot found to leave it now to false. Because now when the computer read here, the computer is gonna be like, okay, yeah, let me check this picture. Okay, the similarity is this. So the similarity is less than 600. Oh, but found is not true. So it will not print the more than one. It will only print the one because right now it's true. Then it will turn false. Now to keep it false, and if you want to create a loop like as soon as Tidus disappear, I want the program to search for him one more time. You can say else if similar, and the same code as here is less than or equal to 600. It's less than or equal to 600. You can just say pass. Just basically the computer says if is false basically here, and still the computer found that is similar less than 600, then just continue, ignore it. Now else, if it's not true and it less than 600, and if it's not less than 600, basically if it's Waka or Lulu for example, just just turn self dot found equals true. That basically saying like then this value here is gonna turn true instead of false. So that means in the next cycle that is actually Tidus one more time and it finds him, it will display the print found Tidus one more time. And just like that, you can make a cycle to only appear one time only and no more than once. Now to test it out, I'm gonna stop it or close it. And now what I'm gonna do is I'm gonna clear this out and I'm gonna run it one more time. It should display right away found Tidus. Yep, found him because he's here. But this time it only did it once. Now I'm gonna attack with him. Ah, damn. Just kill. But anyway, so now it disappeared, right? Tidus is not there. I'm pretty sure the computer is flying all over the place like 10,000 numbers or values. So now I'm gonna start a new battle, and if it's Tidus the first character to show up, and his picture is right there, it should say found Tidus one more time. So it's not Tidus, this time it's Waka. And you notice that it didn't say for a second time found Tidus. But look closely, as soon as I attack this monster, it will tell me one more time found Tidus. You know what? I'm even gonna clear it all. And look what's gonna happen. Attack, successful, and right away found Tidus. Just like that, it told me that he is the one next, or the one fighting, or just told me that the images are very close to each other. So this is how you use norm for one character. But now I'm gonna show you an example how you can send a command to the Titan 2. Let's say that, yeah, fine, we found Tidus, that's great. But what if I want the game to do something? What if I want the game to automatically attack for me? So for that, I'm gonna close it first. So, and then we're gonna work here on the script. We're gonna say self.gcv data. And as you notice, as soon as we created this file, the first few variables that were here, it was self GCV data. I did not make this file, it was already pre-made in the script. So this here is an array, and this array will return values to the Titan 2. It will let know the Titan 2 something that you want to tell, like a number or boolean or something. So right now, by changing this, it used to be here none, right? It used to be like this. It was none first. It means like I want this program, what it's saying is I want you to return the frame and also nothing, just the frame only. That's why it's only displaying here the image. But if you change that, then sorry, if you change the none to self.gcb data, it's gonna actually return the frame and also information for the gpc script to understand. So for that, we're just gonna leave it like that, self.gcb data. Now the next thing is gonna be, how can we send the what how can we do that? How can we send the value if it's true or false? So let's say let's create a new variable here. We're gonna call it self dot is found, is tidus. Let's call it is tidus, the character. And we're gonna call it false first because it's not there yet. Sorry, no. I'm so sorry about that. No, what we're gonna do actually is we're gonna create here the first variable. It used to be picture, but for now we're gonna call it self.gcb, and we're gonna use these brackets. I don't know the name of these brackets, I'm sorry, but they are in the keyboard next to the letter P. So what you're gonna say is the number 0 inside the brackets, then you're gonna say equal, and then you're gonna say false. So every cycle the computer will turn this value here to false. This is, remember, this is an array. An array can have like 5,000 values inside. One value can be 1, the other value can be 0, the other value can be 2, the other value can be 5, and so on and so forth, like forever. So I'm just saying the first value, the first one of all, is gonna be false only. In every cycle, I'm telling that to the computer. But if we get to find tidus, that's the only time that we're gonna say self.gcb of 0 to be true. So remember, first we're turning a false, right? We're saying, okay, everything is false. It will be false. Then take the picture, then find the similarity. If it's similar, then the computer is gonna be like, wait, no. I said false, but no, now it's true. Let's return true. So when the program ends, it's gonna return the value as true, not as false. And with this, we can do the following. So now what we're gonna do is we're gonna open here a new script. We're gonna click on File, New, and we're gonna say minimum GPC script. We can save it on Battle, and we're gonna call it the same thing, Battle. Here is where we're gonna start programming how the way that the Titan 2 will communicate with the computer vision, or better said, with Python. So for that, what we have to do now is we're gonna go to the program, and we're gonna say if, we're gonna say open and closing bracket, or parentheses, my bad. We're gonna say GCV is ready. So GCV ready, that means if the program is ready, we are going to read. So now it's open brackets and closing brackets. But then we're gonna create a boolean here. We're gonna call it the bool. We can say like tidus equals to false. And don't forget the semicolon. The difference between Python and this program is that you need semicolons. So now, because it's false, right? But we don't want that to be false. So we have to say again the name tidus, Tidus, equals to GCV read. We're gonna read it. We're gonna read the GCV data, this one. But remember, because it's an array, we have to say open and closing parentheses, and we have to say 0 and the semicolons. Now we're saying the Titan 2, whatever the value is, whenever it's returned, if it's ready, if it's updated, just pass it to Tidus. I want Tidus to have this value here. Um, I want this value. If it's false or if it's true, doesn't matter if it's false or true. I just want this value here to have it. So now we can say if Tidus, right? And this in the Titan 2 means if Tidus is true. If it's true, then just do an action. If it's false, don't do anything. So for that, we're gonna say now, we're gonna create a combo. A combo is like a set of buttons that you want the controller to do for you. And I want Tidus to attack automatically. It's not a good idea in this game, but I just want him to attack as an example. I'm gonna say attack. Open and closing brackets. Now we're gonna say set value, close it, off, and this is the part that I'm always get confused. I don't know which one is A. It's 1, 2, 3, 4, 1, 2, 3, 4, button 16. So, oops, I always get confused with this. So, yeah, button 16. So, is button 10, 16 right here. To be 100. So, I'm saying like turn the button A to be 100, to be pressed. For what amount of seconds? I want it to be 60 milliseconds. That's the minimum that has been working for me to detect like I press a button. I can do more. I can do I think up to 50, but other than that, usually I get a lot of trouble. So, as you know, in the game, I have to press A 2 times, so that the computer, the not the computer, the game understand that I want to attack is the first A, and the second A is to select the enemy that I want to attack. So I'm gonna add a little delay. So I'm gonna clone it. You can clone it by pressing Control D. And now I just gonna add the number 250. Or no, let's just add 500. That means wait for 500 milliseconds. Then press again A. So now it should work okay, but let's see if that is what I want to do. So the boolean says it's false at first. Then the first thing that the program's gonna do is it's gonna read the boolean from the Python, and then it's gonna assign the boolean if it's true or false to Tidus. If Tidus is true, then I want him to run the combo. So I'm gonna say combo run, and I'm gonna call it, which is attack. You can copy and paste it if you want to. And just like that, it should work fine. Let's see. Usually I have a issue, but this time it went pretty smooth, so that's good. Now you might notice that right now if I run the game, it didn't attack. It still says in my TV, which I'm watching, it says on attack. If as soon as I press the green button, it should automatically attack. Hopefully it does. There you go. I didn't press any button and it attacked for me. So it should do it once again anytime that I enter a battle. And if the character is Tidus, it should do it automatically. Let's see. Hopefully I start a new battle quick. Okay, let's take a look. It's Tidus again. And this time I think it glitched because it didn't do the second attack. Oh, because it went too quick. So I'm gonna add a little delay on this here. So what I'm gonna do is I'm gonna copy this code here and I'm gonna paste it. What I'm gonna do is I'm gonna add the same thing, 500, and I'm gonna click on play. So let's see now. I'm gonna attack with Tidus, and if the second time he attacks automatically, hopefully, and it works fine. Let's see. You notice right away that with Waka it didn't work, with Lulu it didn't work, but now that I'm gonna click the button Y to skip their turn. It should work right away with Tidus when it's his turn. Tidus found, pop, you see, automatically. So I'm gonna do it one more time. I'm gonna click the letter Y in my controller. So I skip his turn. I'm gonna skip her turn, but the next turn is gonna be Tidus, as you can see here. So he should attack as soon as the computer detects him. So at the count of three, 1, 2, 3. There you go. I'm not pressing the button, and I promised you I am not. It's just that the script did it for me because I said the script if you find him and if if all this is true and you're sure that it's true, then just return true. And then my script says here if it's true, right? If it's Tidus, right? If we found him, then I want you to run this set of buttons. And the set of buttons says wait for 500 milliseconds, click A, then wait another 500 milliseconds, and then press A again. So A to select attack and A to select the monster to attack. And yes, so that should be it. That was my goal, to teach you guys how to use the norm. Just to recap, oh, by the way, I forgot this, but I recommend to do it. I really do not know why we have to um, delete the values, which is why I haven't explained it yet, but I just still do it. And if it works for me, definitely, I haven't had any issue. Even if I don't delete it, I haven't had an issue, but I don't want any issue to happen. But anyway, just to recap. Uh, so GCB data holds an array of values that you can send to the Titan 2 for so that the Titan 2 can follow a set of instructions. Um, in here template, it will hold the image that you took with the norm. The norm box is this program that I used on the first tutorial. But once you take the image, you're gonna take that image and you're gonna pass it to the imread. Found is just a little trick that I use so that the code is only runs once and not more than once to prevent glitch or if you want to see an information. So the next step was to turn self GCB data 0 to be equals to false so that every time the code knows like okay, don't do anything yet. Only do something if the value is true. If you find the image on the corner that we specify, which is this one. So, oh yeah, picture, it was the frame, and we're cutting that specific area. This value here is the Y value. This side here is the X value. But we extracted this value with this code here. That is automatically generated with norm, the with norm box. So then we use the value similar, and the value similar just compare the self template, which is this here, reading the image, to the actual image, the frame, which we are cutting from our current frame running on the background. And then we ask for a question. We ask the computer, do you think that this similar value is less than or equal to 600? And if it's true, have you found it before, basically? So if the computer then is gonna say, okay, if this is true and this is true, then just print it one more time. We found Tidus. Then the computer will turn itself into false so that it can only happen one time and not more than once. Then we say GCB data to be true so that the um GCB or this is GPC. Am I saying it wrong? Yeah, the GPC can read this value here because this is being sent to the Titan 2. Then, to prevent repetition, we said if the value is still being less than or equal to 600, just forget about it. If you already found it once and it's still there, just you already told me once. Don't tell me again. That's what this is basically saying. And then else, if it's not there and none of this is true, then just turn true, turn found to true, like search for it. And then the last and final step is to return the frame. You can return here picture, just a reminder, and it wouldn't matter. It definitely doesn't matter if you choose picture or frame. It will not affect the code as long as you're not trying to do something like contours or anything like that. And yeah, and then you return self the GCB data. On the GPC, what we did is we created a boolean file. The reason why we made it a boolean here is because I have this as a boolean. The 0 represent a boolean. So boolean and boolean, both are booleans. And then I just said to the computer, please make sure that it's ready. If it's ready, just give me the value that you have on the array 0. Then if that array 0 is true, then run me this combo. And this combo represents a set of buttons of instructions that I gave to the controller. And that should be it, guys. I know this was a very long and a lot of talking explanation, but I'm trying to cover as much as I can for you guys to understand. It is a 39 minutes, but damn, we make it work. We did it. We made it work. So, and this was the first time me doing the Final Fantasy X, and it works fine. I like it. So, I'm gonna make a third video, but this third video is gonna be more of a it's gonna be about how to implement a template, bunch of files in only one picture. Sorry, bunch of pictures in only one picture, and how to read each different picture individually. You understand? It sounds confusing now, but once I make the video, it will be a little bit more clear. Anyway, guys, thank you so much. I'm sorry to make it so long, but I hope it was clear. And have a great day, guys. Bye.